Do you recognize the person you see on your screen? Yes, he is the great Thomas Edison. Do you know what he is known for? In 1879, he invented the first practical, long-lasting electric light bulb. And since then, our homes are bright even after sunset. You must be aware of the fact that lights in our homes work on electricity. However, they're not the only ones that use electricity. Our televisions, air conditioners, water heaters, fans, and so on also need electricity to function. Laser light or even small flashlights also work on electricity. Imagine a life without electricity in the world today. The discovery of electricity has helped to start a new revolution in the history of humankind. But let's just keep aside all the rhetoric talks and try to understand the real thing.
Concept, that is electric power. Okay, simple definition. What is electric power? Electric power means rate of doing work. Very small. Okay. What is electric power? Rate of doing work. The work done by a substance, that is called as electric power. And the SI unit of power is watt. Okay. Where have you seen this word watt? Most probably everybody has seen it upon the bulb. Okay, just check it out. If you find a bulb in your home, everybody has the bulb. So just check it. In the bulb, the uppermost part, you'll be having a reading of watt. Okay, so that watt indicates the capacity of that bulb. Okay, so SI unit of electric power is watt. And also there is a formula given for electric power where P stands for electric power. Okay, P stands for electric power. P is equal to V by I. P is equal to V by I, where V stands for voltage and I stands for current. So this formula is very important, okay, in solving few problems. But since problem is not there in this year, they have been deleted the problem part. So just remember this formula at least, so that they might be asking it. They might ask it for fill in the blanks or MCQ type. So just remember about this concept of electric power and its formula. So here ends the chapter electricity. Let's see how the resistors are connected in series. Okay, so this is an electrical circuit where the zigzag motions, wherever you can see, those are the resistors. Okay, this is R1, resistor number 1. Here it is R2, resistor number 2. Now these two resistors are connected to a battery, wherein longer end is considered as positive part and the shorter end is considered as a negative part. Okay, now R1 and R2 are connected in a straight line, right? Can you see here? R1, resistor number 1, resistor number 2. It is connected in a straight line. So, when it is connected in a straight line, then that particular resistor connection is called as series connection. Okay? What is it called as? Series connection. And there is a formula. When the resistors are connected in series, the formula given is RS, where resistors in series. RS stands for resistors in series, which is equal to R1 plus R2. Okay, so this is a formula when resistors are connected in series. Now coming to the resistors connected in a parallel, here what happens? R1 is also there, R2 is also there, and also there is a battery. Okay, here what happens is R1 is connected R2 is connected exactly below R1. It is not in a straight line. It is one below the other. It is in a parallel format. So, when the resistors are connected in a parallel format, that is one below the other, then such type of resistor connection is called as parallel resistor connection. Okay, if suppose resistors are connected in straight line, then it is series connection. If resistors are connected one below the other, then that is called as a parallel connection. Now RP, that is resistors connected in parallel. RP, resistor connected in parallel. The formula given is 1 by R1 plus 1 by R2. Next we'll study the factors on which resistance of conductor depends. Okay, factors on which resistance of conductor depends. Now conductor means what? Not a bus conductor. Here conductor means the wire in which electricity pass. Okay, the wire in which electricity pass, then that particular material is called as conductor. Okay, what is conductor? The wire or the material in which electricity pass, that is called as conductor. Now what is this resistance? Resistance means, suppose this is a conductor and here there is a resistance. Okay, what is the work of this resistance is, when the electrons are flowing through the conductor, this resistance stops the electron flow. Okay, and when it stops the electron flow, the electricity is not generated in this wire. Electricity is stopped here. When the resistance comes down, immediately again what happens? Electrons will flow through the circuit. Okay, so that objection which can be seen on the conductor, objection can be seen on the conductor, that is called as resistance. What is resistance? The objection can be seen on the conductor is called resistance. Now there are several factors on which resistance of conductor depends. One is length of the conductor, how long the conductor is, it depends on that. So that is the first point, length of the conductor. Next one is the temperature of the conductor, at what particular temperature the conductor is working, or at what particular temperature the resistor is resisting the electrons, that is a temperature. Second point. Now the third point is material of the conductor, at what particular material the conductor is prepared, at what particular the texture the conductor is prepared, that is a third point. Next, fourth point is cross-sectional area of the conductor. Cross-sectional area means, suppose the wire is this long and one more wire is this long, what we'll do, we'll knot this out, right? We'll tie a knot to the wire and we'll make it a long one. So that particular knot tied, that is called as cross-sectional area of the conductor. Okay, so always remember factors on which resistance of conductor depends. There are 4 different factors. One is length of the conductor, next one is temperature of the conductor, then material of the conductor, and last one is a cross-sectional area of the conductor. So these are the 4 different factors on which resistance of conductor depends. Now this resistors is broadly classified into 2 different types. One is series and one more is parallel. Okay, so when the connection is done, when the electric circuit is connected completely, based on the placement of this resistor is divided into 2 types, that is series and parallel. Move on to potential difference. Okay, so potential difference means electrons move at certain difference at particular pressure. Okay, so electron moving takes place. Suppose this is electron A and this is electron B. Here what happens is, this electron also will be keep on moving, even this is also will be keep on moving, but the difference, there is some distance present in between those 2 electrons, right? So that is a difference of potential. That particular difference we call it as a potential difference, and this potential difference can be measured by an instrument called as voltmeter. Okay, voltmeter is an instrument used to measure the potential difference. What is potential difference? It is a electrons move at certain difference at particular pressure. So that difference is called potential difference. Now SI unit of potential difference is volt. Okay, so volt is a SI unit of potential difference. Now because of the concept of this potential difference, a law has been evolved. That law is called as Ohm's law. Okay, so it is Ohm's law. This is very important question. Now what is Ohm's law? Ohm's law means potential difference across the ends of the conductor is directly proportional to current flowing through it. Okay, suppose this is a potential difference of a conductor. Suppose this is a conductor, so this is a conductor, and here electrons are flowing. Okay, so the potential difference between those 2 ends is directly proportional to what? Current flowing through it. Okay, potential difference between 2 ends of conductor is directly proportional to current flowing through it. That law is called as Ohm's law. Ohm's law is given by a formula, that is R is equal to V by I. Okay, can you see? R is equal to V by I, where R stands for resistance, V stands for voltage, and I stands for current. Okay, current is represented as I, R means resistance is represented as R, and V is voltage is represented as V. So Ohm's law formula can be given as R is equal to V by I. Good morning, students. So today we are going to start a physics chapter, that is electricity. Okay, so hope so you are clear with the introduction part of electricity. Now I shall tell the definition of electricity. So electricity means amount of a charge flow through circuit. Okay, it is a amount of a charge flowing through the circuit. Now what do you mean by charge? Charge in the sense it is electrons. Okay, charge means it is electron, wherein what is the charge of electron? It is minus, negatively charged particle, that is electron. Okay, so this electron will be keep on moving in the circuit. So whenever the circuit is filled with electrons, then we can say in that circuit there is electricity. Okay, so now the SI unit of this charge is coulomb. Okay, this is very important for fill in the blanks. SI unit of charge is coulomb. Okay, now we are speaking about the circuit here. So circuit means what? Electric circuit means what? So the path where electrons flow. Okay, suppose consider this is a path. Okay, so here the electron starts flowing from this end to this end. So this path becomes electrical circuit. Okay, so electric circuit means the path where electrons flow, that is called as electric circuit. Next, there is an instrument used to measure the amount of current. Okay, suppose if this is a electric circuit, in this circuit there will be current flowing. Okay, we should know how much amount of current is flowing through the circuit. For that there is a instrument that is called as ammeter. Okay, so ammeter is an instrument which is used to measure the amount of current flowing through the circuit. Okay, what is ammeter? It is an instrument used to measure the amount of current flowing through the circuit.